Ready-Made Maths YouTube channel. If you enjoyed today's video, or indeed if you've enjoyed any of the previous videos that we've shown so far on Ready-Made Maths, please subscribe to the Ready-Made Maths YouTube channel. Then we can keep you informed with all upcoming videos in the future. Teaching assistant and teacher training in mental mathematics. Today is day 4, and our arithme'tricks for today are 2, partitioning and counting on.
Hello and welcome to day 4 of the Ready-Made Maths YouTube videos. Over the last 3 days we've developed the first 3 mental arithmetic strategies. On day 1 we looked at number bonds, on day 2 it was double and adjust, and on day 3 we looked at round and adjust. What we're going to do today is look at 2 strategies together. These are the 2 most common strategies that you've probably been using over the past maybe 20 years or so, ever since the National Numeracy Strategy came out. These 2 strategies are, as we can see on the board over here, partition and count on. What we're going to do today is investigate both strategies together and then decide for ourselves, is it better to partition sometimes, is it better to count on, or does it not matter for certain calculations? What we're going to do now is look at the 3 calculations here and the 3 calculations down here, and kind of go back in time a little bit to the National Numeracy Strategy, because these were the 2 strategies that were very much advocated by them. First of all, partitioning and then counting on. If we were asked to calculate 35 add 12, this is probably what most people would do nowadays. Rather than using pencil and paper, we just look at the numbers and go, let's just partition them. 30 and 10 equals 40, 5 and 2 equals 7, 40 and 7 gives us a total of 47. That's using partitioning strategy. I've used something there called partition jot, which allows you to do just a very quick jotting to explore what you've just done in your head. I'll actually just put the answer down there. With the next one, 40 and 30, 4 tens and 3 tens gives us 70, and 3 and 2 gives us 5, giving us a total of 75. Again, we can prove all this with resources, but hopefully by the time children are in year 3, they're starting to do these naturally. The third one, 54 and 41, similarly, 5 tens and 4 tens gives us 9 tens, or 90, and the 4 and 1 gives us 5, and that gives us a total of 95. It is really important though, if we are asking children to do these, that they don't refer to that as 4 and 3, or 5 and 4. That's what a lot of children do, and then they tend to record it wrong and get the wrong answer. 40 and 30 is 70, or if they want to call it 4 and 3, 4 tens and 3 tens, 7 tens, 70. And that gives us our total of 75. The other alternative for each of those calculations is to use a count-on method. The count-on method might be for some children a little bit easier. 35 add 10 is 45, add 2 is 47. And now that used to be recorded, and often still is in many schools. The 35, we do a jump of 10, as if we're on a number line to get to 45, and a little jump of 2, which gets us to 47. I won't show all 3 calculations. I'll just look at the last one up here, 54 and add 41. We'd start with 54. Now we could jump in 4 lots of 10, and that's how it would initially be recorded, but eventually it would just be 54 add 40. 54 and add 40 is 94, and then we add the 1 to make 95. Both of those strategies were taught for many years and became quite common, quite popular. I know over the last maybe 4 to 5 years, I've seen less partitioning and certainly less counting on, but it's certainly worth bearing those in mind. Yes, they are mental arithmetic strategies long term, but initially we show them with a jotting and then develop them so eventually they become something that we can do in our head.
As we've just seen, partitioning and counting on for simple calculations, especially with 2-digit numbers, can generally be completely interchangeable. Some children prefer to partition. They'll take, for example, 30 and 10 to make 40 and 5 and 2 to make 7 and just put the 2 together. Other children prefer to count on. They keep the 35 as the whole number, count on the 10 to make 45 and add the 2 to make 47. Similarly, in the second calculation, there's those 2 options again. Do I add the 10s and add the 1s, or do I just keep the first number as a whole number, add on the 10s to that, and add on the 1s to that? Either way is going to get the same answer. It just depends on people's personal preferences. As we start to cross boundaries, the same thing still applies. We've got that option of 40 and 20 is 60, 8 and 4 is 12. That's probably how the majority of children and adults would do that calculation. The alternative to that would be to keep the 48 as a whole number, add on the 20 to make 68, and add on the 4 to make 72. You'll see a similar examples with 57 plus 36 as well. Basically, which of those do you prefer, or do you move between the two? Some children prefer to use partitioning for certain calculations and counting on for others. As we also saw, counting on can be shown using a number line. That can just be a quick sketch. It doesn't need to be particularly neat, as long as the children can show what I'm doing is a two-step calculation. I'm kicking off with 48, I'm adding the 20, I'm adding the 4. I'm starting with 57, I'm adding the 30 to make 87, and the 6 to make 93. That 6 could also be added as 3 and 3 if children prefer to do it that way. But it is really worth encouraging them initially to show they're working out as a jotting, which would either be the partition jot that we saw previously, or the number line jotting for counting on. To see the examples for 3 and 4 digit numbers, please tune in to the Key Stage 2 video on the same topic.
I thought today it might be worth introducing some different resources. So we've got the egg boxes as before. What we've done today is filled them with some gems. We're imagining now we're in year 1 and we've been given the calculation 12 plus 5, and we're just going to show that calculation as a pure count on. Very, very straightforward. Looking at the actual egg boxes there, we've got 12 counters, which is a 10 and 2 ones, or 12 ones. We've got a count on 5, and we just count on 1, 2, oops, that's turned up with a matter, 3, 4, 5, and we end up with, again, we can see it really clearly, 10 and 5 and 2, or 10 and 7 is 17. Again, with counting on, as soon as we move beyond small numbers into slightly larger 2-digit numbers, it really is just a matter of making sure the children know which bit is being counted on. We've currently here got the number 57. We've got packets of sweets this time from a company called Sweet Counter, funnily enough. You've got the tens there, 5 tens, which give us 50. And you've got 7 ones, again, set out in that tens frame formation that we've been looking at for the last few days. Now, what do I need to add? If I need to add ones, well, they're going to go over here. If I need to add tens, they're going to go over here. We're going to do 57 out of 10, very, very straightforward. All we do is we introduce a new 10. Therefore, the only digit that's going to change will be the tens digit. If I was to write the calculation out, oh, that's not. So, 57 add 10 equals 67. And from that point, the children can see we started off with 5 tens and 7 ones, which is 5 tens and 7 ones. We added one more 10, and we now have 6 tens and 7 ones. So that's the digit that's changed. Again, looking at another example of counting on, this time we're going to count on a multiple of 10. Usually counting on is just done with multiples of 10 and multiples of 100, so it becomes generally a mental strategy. But as a quick visual, we've got 50 and 8 with the numicon. We're going to add 40, so we're going to add 4 tens. Very straightforward. 1 10, 2 tens, 3 tens, 4 tens. That gives us a total of 98. Very, very nice visual there. What we can also see is 98 is 2 away from 100 by looking at the way that the visuals have been represented. So that one. We're now looking at base 10. The calculations changed slightly. We're still adding multiples of 10. You can see 85 represented as 50 and 30 to make the 80 on our 5 ones. What I want to do now is just pause the video just for a second. What do you think is going to happen when we introduce the extra 50 as part of our count on? As we introduce the extra 50, we're going to count on 50. We've currently got 8 tens. We need another 5 tens. If I put them there, we can actually see clearly we've got 13 tens. We could just count on in tens if we wanted to. 95, 105, 115, 125, 135. But that's not an efficient way to do it. Let's think about the calculation. We've got 85, that's 8 tens. We're going to add another 5 tens. We've got 13 tens. We exchange 10 tens for 100, and we now have 135. Which digit has changed this time? Well, we've added the tens, 85 and 50. And what's happened now, because we've gone over into a new 10, we've actually changed the tens, and we've also gone into the hundreds as well. But we can still see we've got 13 tens in total.
As we've seen on all of the days so far, even though we're starting with a mental calculation strategy, we're going to initially introduce it using visual apparatus These are just some similar examples to the ones we've just looked at. If we're counting on in ones, our 13 and 4 gives us a total of 17. If we're counting on in tens, we've currently got 5 tens and a 4. We just add one more 10. We've now got 6 tens and a 4, or 64. And even when we're counting on in hundreds, we've currently got 647. We add 100 to get 747. At the moment, because we're not crossing a boundary, when we're adding in ones, the ones digit changes. When we add in tens, the tens digit changes. And when we add in hundreds, the hundreds digit changes. The visual calculation policy, or the MVCP, that I've mentioned on each of the previous days, also shows examples of counting on that can be used in class as part of a working wall. You can see examples there in ones, in tens, in hundreds, and even in thousands. Counting on really is a straightforward mental arithmetic strategy where we're just looking at one particular element of the number that we're counting on. When counting on is being used to add two digit numbers up, we can do it in two separate ways. Initially, when children, let's say in year 2, are learning to do a forwards jump as such, 43 add 24, they would probably start off by going 43, 53, 63, and then they count on 64, 65, 66, 67. That needs to be developed as soon as possible, so they just count on the 20, 43 and 20 is 63, 63 and 4 is 67. The second example shows that 57 add 25, we're just going to add the 20 and add the 5.
We're going to move on now to visualising partitioning as a strategy. As we've just said, counting on is usually just for adding multiples of 10 and multiples of 100. Those we saw earlier, it can be done as a number line strategy. But partitioning, again, starts off as something that children in probably year 2 will be doing visually, and then eventually becomes something that they'll be able to do in their head. Using the sweet examples again, we've got 43, 4 packets of 10 sweets and 3 individual ones, and 21, 2 packs of 10 sweets and then 1 individual one. We're not doing column method, we're partitioning. So the first thing we do is we put the tens together and then we put the ones together. Put the tens together and we end up with 6 tens. We put the ones together, we end up with 4 ones. Answer 64. Exactly like we showed on the board earlier on. We're now looking at a partitioning example with 2 digit numbers that's going to involve one exchange. We've got 57 add 25. Very appropriate for year 2, initially to do as a partition with visual apparatus, and then eventually to do in their head or with a jotting. 57, 5 tens and a 7, 25, 2 tens and a 5. As before, what we'll do is we'll put the tens together and the ones together. So there's the tens, there's the ones. I want to put those like that. We can now see the number of tens that we've got is quite clearly 7 tens at the moment. Over here, we've got 7 and 5, which gives us 12. To prove that it's 12, we'll put the 10 over the top of there and the 2 over there. 7 and 5 is 12. So what we've now got is 70, add 12. What's the total? Well, I'm going to put that 10 there. I'm going to put the 2 there. And it gives us the total 82. 70 and 12 equals 82.
Partitioning is probably the most common strategy that is taught in primary schools, and as we can see from the pictures here, it's very, very useful to start off with practical apparatus. We've seen quite a few examples that I've just demonstrated to you. There's just a couple of examples here from the concrete pictorial policy showing 43 add 24 with base 10 and with place value counters. You can also see 75 add 52, again with base 10, with place value counters, and underneath actually as a counting on strategy. As soon as children have got that idea, they understand what partitioning is, and we want to then develop it into mental mathematics, that's when the partition jot comes in. As you can see there, it does initially start as an actual written jotting, so the children will write the calculation, 43 add 24, they will put the arrows to the appropriate place, they will do 40 and 20 is 63 and 47, they'll write all of that down and get the total 67. As they move, let's say from year 2 into year 3, they just look at the calculation now and go 40 and 20 is 60, 3 and 1 is 4, 60 and 4 is 64. So it does then become just a mental strategy where they hold the 2 parts of the numbers in their heads. You can see the same thing developing here, even when we're crossing the boundary. 50 and 20 is 70, 7 and 5 is 12. The whole thing can be written down, as you can see in the partition jot. Just the actual numbers 70 and 12 could just be written down as a little jotting to help hold the numbers in your head. Or eventually, as you can see from the MA3 up there, the whole thing is just held in the children's heads and they get the answer 82. Usually by year 4, that's what most children are able to do if they've practiced this skill enough. Again, both of these strategies, counting on and partitioning, if you want to see how they can be developed further and see the apparatus work and also the visual calculation policy and how it develops into Key Stage 2, please take a look at today's other video.
I've now moved over to the ready-made maths number wall as we've done it every day. We are just looking at 2-digit calculations, but I've just chosen just 4 sets of numbers. What you're going to do now, we're going to pause the video, have a quick look and just say to yourself, am I going to partition or am I going to count on? Which of the strategies would be more applicable for each of those calculations? So we'll just zoom in on the board and pause the video now. Looking at 48 and 24, either way would work. 40 and 20 gives us 60, 8 and 4 gives us 12, and 60 and 12 give us 72. A lot of children just prefer to keep the first number in their head. Count on the 10s, gets us to 68, and count on the 1s, which gets us to 72. Either way, that would work. Looking at second calculation, 71 and 55, probably for that one I would partition. I'd look at my 7 10s and my 5 10s, so I'd be doing the partition jot. For that one, we've got 12 10s or 120, and then just 5 and 1 is 6. So again, a straightforward 126. This example, again, I'm not going to do a jotting for it, 28 add 50. We can actually do it either way around. We can start with 28 and count on our 5 10s, which will get us to 78, or 2 10s and 5 10s. Or we can start at 50. 50 add 20 is 70, and 8 is 78. Again, a relatively straightforward count on. Both of those ways would work. Similarly, with 132, add 21. Most children do choose to partition, but to be honest with that one, probably 132, add 20 is 152, add 1 is 153, would be just as easy. Again, we could just partition them separately if we felt like it. It's really nice to have a range of numbers like this. I'm just going to go onto the table and just randomly select some numbers this time from a big pack of number cards. These are the sense of number reasoning cards, which can be got from senseofnumber.co.uk. It's a pack of 144 cards, which have got all the table facts from 1 times 1 to 12 times 12, and there's also all the prime numbers as well. So you end up with a really good range of numbers that you can choose from for activities such as these. I've no idea which ones I'm going to choose, so I'll just randomly select a number here. Number 6, that's a bit too easy. I think I'll choose a different one. Number 12, far too easy. 12 add 5, 17. So that's a bit better. 77, and to a 77, I'm going to add 33. Again, a bit too easy. I'm going to try and find one that will actually be a little bit more complicated than that. There we go. A little bit harder. 77 add 14. With that one, I'm just going to count on 77 add 10 is 87, add 4 is 91. I'm hoping eventually I'll be able to find one that's a little bit trickier. So there's a 55, and I'm going to add to 55 18. I'm going to try and find one that's a bit harder. There we go, oh, much better. 55 adds 72. I will put the largest number first because that's always generally a better strategy. What am I going to do now? With that one, I'm going to partition. I'm going to put my 7 10s with my 5 10s to give me 12 10s or 120, and I'm going to put my 5 with my 2. 120 and 7 is 127. Last one, I'm going to actually now extend the activity and just see if I choose 56 and 15 and 33. Probably now counting on is not going to be as appropriate, but will the partitioning strategy work with 3 numbers? Well, let's have a look. We've got 5 10s and 1 10. That's 6 10s, and another 3 10s. That's 9 10s or 90. So I can write down 90 on there, and I'm going to add that to 6 and 5 is 11, and 3 is 14. 90 add 14, 90 and 10 is 100. Again, partitioning, which gives us 104. So just a little bit of homework as we do every day. I've actually added a few different numbers to the number wall. I've added a few slightly larger 2-digit numbers. I just think it's really good to get that practice in partitioning in as many different ways as possible, and also counting on. So what I'd like you to do is just basically have a look at the number wall, and again, depending on obviously the ability and level of children that you're working with, or how well you want to challenge yourself, have a look at those numbers and basically just select initially any two numbers, and another two numbers, another two numbers, another two numbers, and just practice partitioning those together. Then build it up to 3 numbers. That's it for today. Thank you for joining me for day 4 of the Ready Made Maths YouTube mental mathematics videos. As we've seen today, on day 4, we've been looking at 2 strategies. The strategy of counting on, which we've mainly used with apparatus and number lines, and the strategy of partitioning, which we've demonstrated with all the apparatus. We've also looked at how it starts with 2-digit numbers and builds up to 3, 4, and eventually even becomes decimal calculations. On day 1, we looked at number bonds. On day 2, we looked at double and adjust. On day 3, we looked at round and adjust. As I mentioned at the start of the week, we've now got a bank of strategies that we've been building up all week. I've just kind of given them little nicknames. Number bonds is numbo. Double and adjust is known as da. Round and adjust is ra. Count on is ko. And partition is pa. There is a reason for that. You'll meet that in some of the upcoming sessions. What we're going to be doing tomorrow on day 5 is kind of bringing things together and looking at the final strategy, which is called manipulate the calculation. And what we're going to look at is how we can build all of these together and make calculations even easier. That should then take us into next week, where we can start to play a range of different mathematical games that will really give the children a lot more fun when they're doing any of those 5 particular strategies. So I hope you've enjoyed the session. I've really enjoyed delivering the 4 sessions this week, and I hope you'll continue to watch the future videos and continue to develop our mental arithmetic strategies. Thank you very much, and I look forward to seeing you all again tomorrow.
That's the end of day 4. I hope you've enjoyed the training session today, and that you're going to come back tomorrow for day 5 when we bring all of those strategies together. As I mentioned at the start, it'd be absolutely superb if you've enjoyed today's video and the other videos. Please subscribe to Ready Made Maths YouTube, and also please follow me on Twitter at Ready Made Maths. The more people that follow there, the more people I can inform about the future videos that are going to be coming out over the next few weeks. Thanks very much, and I'll see you all tomorrow.